Imagine you're standing in the back of this cavernous, dimly lit lecture hall. You need to broadcast a crisp 1080p close-up of a speaker to an online audience, but you have absolutely no camera crew.
Right, and just a single Ethernet cable to somehow make it all happen.
Exactly, just one cable. Today, we're doing a deep dive into the technology that makes that seemingly impossible scenario, standard practice. We're looking at the specs of the Bolin Technology B7-220 PTZ camera, pulling from HDTVSupply data, to understand how professional-grade broadcasting is just becoming so highly automated.
Yeah, it's pretty incredible how fast things are moving in this space.
Totally. I mean, when I first looked at the physical specs for this hardware,
Yeah.
specifically the 340 degrees of pan and 180 degrees of tilt, I couldn't help but picture, like, a robotic owl with a telephoto lens strapped to its face.
A robotic owl is actually a great way to visualize it.
Right. But, okay, I do have to push back on one of the big selling points here.
Okay.
It posts a 20x optical zoom.
Hmm.
And usually the second you start zooming heavily, especially in that dim lecture hall scenario we talked about, you just destroy your image quality. You end up with this blurry, grainy mess.
Well, yeah, I mean, that is a completely fair assumption if you're basing it on older tech.
Right.
But the reason the image remains crisp here isn't just about the glass and the lens.
It's the sensor, isn't it?
Exactly. It's the sensor sitting right behind it. This camera uses a 12.8-inch, 2.13 megapixel CMOS sensor. And to translate that, in the camera world, a larger sensor basically acts like a bigger bucket for catching light.
Oh, okay, so a bigger bucket pulls in way more light.
You got it. That larger light bucket is exactly why capturing 1080p video at a smooth 60 frames per second actually works in a dark room.
So the hardware physically pulls in more light, but there's also a software element keeping things sharp, right? It has an AI-powered face analytical engine.
Yeah, that's the real brains of the operation.
So I'm assuming this means the AI actually takes over the exposure and focus settings, so the lens isn't just, blindly hunting for a subject in the dark.
That is the core mechanism, yeah. The AI locks onto a face, prioritizing the subject's clarity. But to deal with the inevitable digital noise like that static you see in low-light video, it uses advanced 2D and 3D noise reduction.
Wait, what is the actual difference between 2D and 3D reduction?
Good question. So 2D reduction compares pixels within a single frame to just smooth out the static. But 3D reduction compares pixels across sequential frames.
Oh, wow, so it tracks time.
Exactly. It tracks moving objects to eliminate noise without blurring the motion. The result is a clean, sharp image, even when you are zoomed in 20x in the back of the room.
Okay, so the AI and the sensor make sure the image is perfect, but I mean, a perfect image is completely useless if you can't actually get it out of the camera and to your audience.
Right, the connectivity is huge here.
Yeah, looking at this, it's less like a standard camera and more like a network switch that just happens to have a lens attached to it. It can output via HDMI, 3G-SDI, USB-C, and gigabit Ethernet all at the exact same time.
The utility of that simultaneous output is massive for production architecture. You can route your high-def video to an in-room monitor for the live audience using the HDMI port.
While you're also streaming online.
Yes, simultaneously dual streaming a live feed to the internet over your IP network using that gigabit connection. You're handling in-house AV and global broadcasting from one single hub.
And doing it without a massive bundle of cables tripping everyone up because it supports PoE,
Right.
power over Ethernet.
Right. So that single network cable we mentioned in our opening scenario, it handles the power supply, the high-quality video transmission, and all of the camera control inputs.
Which fundamentally changes the logistics of capturing live video. I mean, if you are outfitting a corporate boardroom, an education center, or a house of worship, you no longer need an entire team to run a multi-angle shoot.
You really don't.
Because you can program up to 255 specific position presets via a network controller. At a price point of $11,195, this magnesium alloy gear is essentially an indicator of a massive industry shift.
Oh, absolutely.
A solo user can just push a button, and the camera silently and smoothly glides to the exact framing they need, mimicking the work of a whole live production crew.
It basically creates a fully automated one-person production studio.
Which raises a really provocative thought for you to ponder long after we wrap up this deep dive.
I think I know where you're going with this.
With AI natively managing facial exposure and focus, and automated presets handling the framing perfectly over a single network cable, are we approaching an era where the human camera operator is just entirely replaced by algorithms?
It's a heavy question.
It really is. When our robotic owl essentially drives itself, what happens to the human art of cinematography?